Question 1. A company uses Azure FileSync to consolidate several branch office file servers into a central Azure file share. They want to ensure that infrequently accessed files are automatically moved to Azure Files to free up local disk space, while still appearing locally accessible. Which Azure FileSync feature enables this functionality? Option A, multi-site sync. Option B, namespace uniformity. Option C, cloud tiering. Option D, conflict resolution. The correct answer is cloud tiering. Here's the explanation. Cloud tiering automatically moves infrequently accessed files to the cloud endpoint, Azure File Share, leaving reparse points, stubs, on the local server, thus freeing up local disk space. Question 2. When Azure FileSync is configured, how are changes detected on a server endpoint, on-premises Windows server, compared to changes made directly on the cloud endpoint, Azure File Share? Option A. Changes on both endpoints are detected near real-time using the Windows USN journal. Option B. Changes on both endpoints are detected by enumerating the share once every 24 hours. Option C. Server endpoint changes are detected near real-time via the USN journal, while cloud endpoint changes are detected by enumeration, potentially taking up to 24 hours. Option D. Cloud endpoint changes are detected near real-time, while server endpoint changes are detected by scheduled scans. The correct answer is server endpoint changes are detected near real-time via the USN journal, while cloud endpoint changes are detected by enumeration, potentially taking up to 24 hours. Here's the explanation. The Azure FileSync agent on Windows Server uses the USN journal for near real-time change detection. Changes made directly to the Azure File Share are detected by enumeration, which can take up to 24 hours, though often faster. Question 3. In a scenario where two different server endpoints in an Azure FileSync sync group modify the same file concurrently, resulting in a conflict, how does Azure FileSync resolve this? Option A. It prompts the administrator to manually resolve the conflict. Option B. It automatically deletes the older version of the file. Option C. It applies a last writer wins policy and renames the conflicting file with the server name and timestamp. Option D. It prevents concurrent modifications, requiring files to be locked before editing. The correct answer is it applies a last writer wins policy and renames the conflicting file with the server name and timestamp. Here's the explanation. Azure FileSync uses a last writer wins policy for conflict resolution. The file that was last written is kept, and the conflicting version is renamed to preserve both. Question 4. What is Azure Queue Storage primarily designed for? Option A. Storing large, unstructured binary data objects like images and videos. Option B. Providing shared file access for cloud or on-premises applications using standard SMB protocols. Option C. Storing large numbers of messages for asynchronous communication and decoupling application components. Option D. Hosting relational databases with advanced query capabilities. The correct answer is storing large numbers of messages for asynchronous communication and decoupling application components. Here's the explanation. Azure Queue Storage is a service for storing large numbers of messages, crucial for asynchronous communication and decoupling application components. Option A describes blob storage, Option B describes file storage, and Option D describes Azure SQL Database or similar. Question 5. A developer sends a message to an Azure queue. A worker role retrieves the message for processing. If the worker role crashes before it can successfully delete the message, what happens to the message? Option A. The message is immediately moved to a dead letter queue. Option B. The message is permanently lost from the queue. Option C. The message becomes visible again in the queue after its visibility timeout expires. Option D. The message is automatically re-queued with a higher priority. The correct answer is the message becomes visible again in the queue after its visibility timeout expires. Here's the explanation. If a consumer fails to delete a message before its visibility timeout expires, the message automatically becomes visible again to other consumers, ensuring at least once delivery. Azure Queue Storage does not have a built-in dead letter queue. Question 6. Which statement accurately describes a key difference between Azure Queue Storage and Azure Service Bus queues? Option A. Azure Queue Storage guarantees FIFO, first in, first out, message ordering, while Azure Service Bus does not. Option B. Azure Queue Storage has a built-in dead letter queue, DLQ, for messages that fail processing, while Service Bus does not. Option C. Azure Queue Storage messages can be up to 64 kilobytes in size, whereas Service Bus messages support much larger sizes, up to 100 megabytes in premium. Option D. Azure Queue Storage supports transactional send/receive operations, while Service Bus does not. The correct answer is Azure Queue Storage messages can be up to 64 kilobytes in size, whereas Service Bus messages support much larger sizes, up to 100 megabytes in premium. Here's the explanation. This is a critical distinction. Azure Queue Storage has a strict 64 kilobytes message size limit. Service Bus queues support larger messages. Azure Queue Storage does not times guarantee FIFO or have a built-in DLQ, and does not support transactions. These are features of Azure Service Bus queues. Question 7. In Azure Table Storage, what combination uniquely identifies an entity and is crucial for efficient data access, partitioning, and entity group transactions? Option A. Table name and timestamp. Option B. Row key and timestamp. Option C. Partition key and row key. Option D. Table name and partition key. The correct answer is partition key and row key. Here's the explanation. The partition key and row key together form the unique primary key for an entity within a table. The partition key groups related entities, influencing physical storage and query performance, while the row key uniquely identifies an entity within that partition. Question 8. A developer needs to perform multiple atomic operations, insert, update, delete, on several entities within a single Azure Table Storage table. What is a key constraint for ensuring these operations can be grouped into an entity group transaction, EGT? Option A. All entities must belong to different tables. Option B. All operations must target entities with the same row key. Option C. All entities must reside within the same partition key. Option D. The total size of all entities must not exceed 64 kilobytes. The correct answer is all entities must reside within the same partition key. Here's the explanation. Entity group transactions, EGTs, are atomic operations that are strictly limited to entities within a single partition. This ensures strong consistency for those grouped operations. Question 9. Which characteristic best describes Azure Table Storage's approach to data structure, making it suitable for varying data types and agile data models without a predefined blueprint? Option A. Strongly typed schema. Option B. Relational schema with foreign keys. Option C. Schema-less design. Option D. Fixed column structure. The correct answer is schema-less design. Here's the explanation. Azure Table Storage is schema-less, meaning each entity can have a different set of properties without needing a predefined table structure. This provides significant flexibility for applications with evolving or varying data models. Thanks for watching. Please subscribe to my channel.